Okay. My name is Dr. Jonathan Brame. I am a research environmental engineer in the chemistry branch of the environmental lab. I'm going to show you today an abrasion chamber that we use to study the release of nanomaterials as part of the environmental lab's nanotechnology focus area. So this is our abrasion chamber. You can see inside it's based loosely off of a Tabor abrasion chamber, but with a few modifications. We use circular discs that we abrade, and the idea is to look at these materials and see if a material that contains nanomaterials, in this case this little puck contains carbon nanotubes, as we abrade it or sand it, does it release carbon nanotubes? Are those carbon nanotubes embedded inside the polymer? Are they released separately? Or are they maintained on the puck and just the polymer is released itself? So this is the chamber. Inside we have a motor that spins the sample, and the sandpaper that's attached to this arm that we can lower onto the sample. Next to the sample we have the inlet where we pump the material out during the abrasion. That goes over here to an impaction chamber where the large particles are knocked out. After the impaction chamber, the particles pass through a four-way splitter, and that distributes the samples to the two collection instruments and the two filters that we use to analyze the materials after the abrasion. The two instruments, this one is a condensation particle counter, and that gives us an idea of the total particle count in a range from about 10 nanometers up to about 10 micrometers. This instrument is a fast mobility particle sizer, and it gives us information about the particle size distribution from 5 nanometers up to 550 nanometers. So with that, I will close the chamber. We set up the system so that the same amount of air that we're pulling out to all of our instruments is equaled by the amount of air that we're pumping in through a HEPA filter. So we allow the chamber to pump down for 5 or 10 minutes until the condensation particle counter tells us that we're at a good baseline, which is usually between 5 and 10 particle counts per cubic centimeter. So once the sample has been in the chamber and it's been allowed to equilibrate, I usually monitor the condensation particle counter when it gets down to baseline, which for our chamber is, like I said, usually under 5 particle counts per cubic centimeter. Then we're ready to start the test. So I try to start the fast mobility particle sizer and the condensation particle counter software simultaneously, which are on these two laptops. Now I let the sample equilibrate for about a minute to establish a baseline on both instruments prior to starting the abrasion. Then I allow the abrasion to run for a set amount of time, in this case 4 minutes of abrasion, then turn off the abrasion and allow both instruments to come back to baseline so we can see the whole cycle of baseline, abrasion, return to baseline. Once we've established our baseline, we can go ahead and start the abrasion. And you can see the increased particle count on both of the instruments on the computers. This is the data coming from the condensation particle counter. You can see after we established our baseline and started the abrasion, an increase from 2 particles per cubic centimeter up to about 9,000 particles per cubic centimeter. And then it's decreasing out to a steady rate as the abrasion continues. The data from the fast mobility particle sizer is a little bit more complex. For each time point, it gives us the entire particle size distribution. So you can look at it in a 3D plot and see as time progresses, you see where the initial start of the abrasion was, and then it's returned to baseline. And here, on this axis, we can see the particle size distribution. So during the abrasion, we see most of the particles were released in this higher particle size, with peaks in the middle and a very low particle size as well. In this case, as we abrade the nano bronze, we see a peak in the 7 to 15 nanometer range and another in the 20 to 50 nanometer range. The bronze nanoparticles are about 40 nanometers in size, so we could have release of nanoparticles with this abrasion. Once the abrasion time is complete, we shut off the abrasion and allow the system to return to baseline. You can see on the surface where some of the particles have attached to the window, and you can certainly see inside the chamber the particles that have been released during the abrasion. So this data abrasion we can use to look at the nanoparticle release from a wide range of products. For example, this is a piece of concrete that's been treated with titanium dioxide. The idea is that the titanium dioxide will help keep the concrete from wearing out. It will help keep bacteria from growing on the concrete and allow it to last longer. We did an abrasion test of this material before and after it's been UV treated. So this material has been UV treated, and we'll see if the release of nanoparticles is greater after UV treating than before. We can use some of this data to determine for different materials if there's a greater or lesser risk of release from titanium dioxide in concrete versus bronze in plastic, and then determine what impacts that will have on the environment or human health.